So today's lesson, we saw that one problem. For the installation shown below, we need to determine is a consumer mains voltage drop, B sub-main voltage drop, C final circuit voltage drop, and D total voltage drop. So this is as our problem given. So here you can see that here is point of supply, and there are three-phase wire and connected to the main switch board and single-phase wire. This is the connected between the main switch and the distribution board. This is a sub-main. And from the distribution board to the load, this is final circuit. So all the sub-main and final circuits are the single phase. And point of supply to main switch board is consumer main is a three-phase supply. So in this case, our consumer main cable size is a 35 millimeter square HLPE. So this is the copper cable. So the how to connect is a leaflet touching. So leaflet touching. In this case, maximum demand 125 ampere. The length is 36 meter. So this is the consumer main. And sub-main, the wire size is 10 millimeter square, V90 wire, and this is the copper. Is the connection, the copper wire, and also the maximum demand 50 ampere. Length is 25 meter. And final circuit, cable size 4 millimeter square, V90. So this is the copper wire. The 2C plus E means the 2 cores and the hard wire. 2 cores, so this is mean the 2 core mean this is the sub-main single phase system. Also the copper 2C plus E. So this is will be the also the this is the 2 core and the arc. So this is the also single phase. So maximum demand 25 ampere, length is 31 meter. So those are the specification of the consumer main, sub-main, and the final circuit. Okay, so firstly we have to find out the voltage drop. So to find the voltage drop, we have to use this formula. VD equal to VCLI divided by 1000. So VC is the unit voltage drop. We have to find from the table 41 to the 50. A is the length of the wire and I is the maximum demand current. Those things you have to find out. So in this case, a leaflet touching. So they are table 40 to the 50. Those tables are for the unit voltage drop. So how the tables are which table have to utilize? We have to use this equation, this relationship. Table 40 single pole. This is the 3-phase installation. We use table 40. Table 41 copper. Table 40 copper single pole 3-phase. Table 41 copper single core leaflet. Table 42 copper multi-core. And similarly, table 43, 44, 45 for the aluminum, 46, 47, 48 for the flexible cable, 45 for MIMS, and then 50 is the area conductor. So this is the how tables are, which is the material of the cable, and how is the installation method. Depending on the material table and the cable and the installation method, we have to select the appropriate table. So in this case, this problem is a copper single core, and this is a 3-phase. So this is the wiring enclosure. So we use that table 41. So we apply that table 41. Leaflet touching, we use the table 41. So in this case, we find out the table 41. So HLPE is 110 degrees centigrade. So we use the HLPE table. So table 41, we look at the table 41 here. So HLPE. So HLPE is 110 degrees centigrade. And also from this table, you can see that here is a done. It's crossing the area of cable, and this is a temperature. So this is the temperature. So we have to select that this table. This from this column, we have to select the appropriate crossing the area, and then we have to select the VC value. So this value selection, what you get is a 35 millimeter square, 110 degrees centigrade. So here is a 35 millimeter square, 110. So what you have to use is 1.25. 1.25 millivolt per ampere meter. So this is a 35 millimeter square, 110 degrees centigrade. 1.25 is substitute. So substitute there 1.25. But this is for the 3-phase VC. what you want is we need a single phase BC because of we have to utilize it as a single phase system. So the single phase BC is 3-phase BC divided by 0.86 is that formula. So the 1 by 2 divided by 0.86 is 1 by 4 millivolt per ampere meter. So this 1 by 4 that we substitute in BC. Then is already given a 38 meter and the maximum demand current 125 divided by 1000, you call it 6.84 volt. Similarly, we also have to use it as sub-main because sub-main is a multi-core cable. So this is for the 2-core and RC. This is a multi-core cable. So the multi-core is where to utilize the table 42. So this is the table 42 used here. So the 10 millimeter square and the V90 90 degree centigrade. So 10 millimeter square, 90 degree centigrade. Table 42. We select the table 42. 10 millimeter square, 90 degree centigrade. So this is for the 4.05. So this is for the, we call it 3-phase voltage drop. So 4.05. 4.05 divided by 3-phase voltage drop. 0.86, you got the 4.676. So we substitute here, V equal to VC by 1000. 4.676 multiply 25 into 50. 25 is a net, and 50 is a 50 is a maximum demand current, and we got a 5.845. Then we also use a final circuit. Final circuit is a 4 millimeter square. 4 millimeter square, 90 degree centigrade. So 4 millimeter square, 90 degree centigrade. We utilize the tables 42 as well. So in this case, from the 4 millimeter square, 90 degree centigrade. So you got 10.2. So this 10.2 we substitute here. 10.2 substitute. So 10.2 divided by 0.86, you got 11.77 volt. So this voltage is VC. This is substitute. Then is a given there's a 31 meter. And current is a 25 ampere. Substitute here. And we got a 9.12 volt. Then we find out the total voltage drop. So total voltage drop is summary, consumer main, summary, final circuit, you add everything, you got a 24.1 volt. So this is the way we calculate. And this one is a dilating factor. When the multi-phase circuit are running in the same conduit or trunk, the dilating factor is utilized to increase the current carrying capacity and after the order the conductor size. Because of the in the single, all the multi-phase circuit are run in the conduit, so they are producing the inducer voltage. Because of the magnetism, negative magnetism, inducing the induced voltage. So this induced voltage will increase the current. So this is why we have to change the cable size. We have to select the bigger cable size. Okay, so based on this one, we select this problem here. The maximum demand current of the sub-main in the non-domestic installation is calculated to be the 120 ampere. So this is maximum demand current 120 ampere. The selected cable is a 4-core non-armor V90 insulated and a sheeted circular copper conductor. The installation of cable is clipped directly to the internal wall with the 4 other circuits, all touching open to air and produced by the circuit breaker. Length is 50 meters. So this is for this cable and then the other 4 other circuits they are connected together. They are touching, they are open to air, and they are protected by the circuit breaker. Length is 15 meters. So in this case, we have to find out. In this case, the installation is 4-core. 4-core means a 3-phase wire is a 3 active wire, is a 3-core, and then additional and neutral wire is this is a 4-core. Open to air, this is the unenclosed. So that we have to select that table 3/1. Table 3/1 unenclosed. So that firstly you look at the table 3/1 unenclosed. So we look at the table 3/1 back. Okay, this is a table 3/1. Table 3/1 is select and 3-core. So this is 4-core means 3-core plus 1 neutral wire. 3-core. 3 go is a which table, which row you have to select. This is a 3 single go given. 3 single go given. So this is a 3 go given. Look at here. 3 go given. 3 go given. We have to select that item 10 or 11. So 10 or 11 you have to select. In this case, table 13, 14. This is for the V90. V90 is a V75, V90, and V115. So this is three saturation. So this gives us our table 13, 14, or 15 you have to select. So I done 10 to 11 to be selected. So that this is 3 go. So in this case, that table is V75 because of the given is a this given is a V90. V90 so is given. So this is therefore that we have to select the row 13 have to be selected. Clip it to the wall. So in this case, clip it to the wall is a row 13 have to be selected. Three single cable clip it to the wall. So this is a 3 go cable. This is for a suspension. But 3 go cable clip it to the wall is a this is a we have to select the row 13. 3 go cable. So the 3 saturation 11, 10 or the 13. 11, 10 is we have to select on the supported by the ladder or vertical or suspension. In this case, item 10 to 11 to be selected. Row 10 or 11 selected. But here is a clip it to the wall. Therefore, we have to select the row 13. 3 go cable, clip it to the wall, row 13 selected. So table 13, 14 or 15 have to be selected. Table 13, 14, 15. And derating is the tables are 22. So they have to be find out. So in this case, clip it to the wall, row 13. In this, so column 5 to 7 or the row 50, column 4, 5. So in this case, 13 for the V75, 14 for the V90, 15 for the V11, 120 degrees indicate. And table 22 is a derating. So those things I have to find out. So based on the here, we have to find out the derating factor. The derating factor is table 22. So there will be the touching of space or touching. So this is the way to select. So we look at the table 22. We look at table 22. This is the derating factor. From here we got there's a derating. So we look at the table 22. So all are touching. So all touching. So here we see a derating table. So derating is given the item 3 or 4 because of the clip it to the wall. So item 3 or 4. Item 1 is a bunching air, 2 is a bunching surface enclosed, 3 or 4 is single layer on the wall touching. So therefore that you have to select the item 3 touching. So this is the item 3 touching, and we look at the how many circuit. So how many number of circuit we look at? How many number of circuit is a 5 circuit. With the other 4 other circuit mean this is the 5 circuit. 5 circuit item 3. So 5 circuit item 3 you look at. So this is the item 3. So 5 circuits. So this is the reading factor is 0.73 we got it. So this is 0.73. This 0.73 we got. So this 0.73 is a derating. So the maximum demand current divided by 0.73, you got a 164.3 ampere. So this current you have to be utilized. Because maximum demand current is at 120 without derating. If you derate, derating factor is 0.73. So 120 divided by 0.73, 164.3 have to be utilized. So this is the name we got as a derating factor. So based on this derating factor, you have to find that this is the maximum demand current we can get by using this derating factor. So that this problem we have to find out there's a deleting factor. So by this way we can find out the deleting factor. So this is the thing, maximum demand current, we get it. So this problem is we can find how to find out the deleting factor. Okay, the next one we can talk about the electrical engineer trade practice. To page 22. Okay, the next one will be last week we talking about I had talked about the alternatives power supply and standby generator. Now we have to think about the factors to be selected the alternator. In this case, we have to concern about the voltage, current, frequency, power, and power factor. Those are the factors to select the alternator. So this is main power supply, circuit breaker 2, 3, 4, and standby generator, essential load, non-essential load, we connect it. In this case, a circuit breaker one is a manually operated